Hello, welcome back to our seminars about tips to help researchers. And today I'm gonna present about something that consumes a lot of time and energy from us when we are doing research, and I mean all of us, because most of us here are graduate students or researchers, and maybe even an undergrad who is doing literature review or trying to write a research paper. It's known that when you are writing a research paper, of course, from the beginning, you will have a good idea, and after you have that idea, you will need to connect your idea to the literature, and that is to look in the literature for papers or written documents in general, research articles, papers, books that are research related to your research. Particularly when we are writing papers, we have that a very important part of our paper, that is the related work. And if I ask you, all of you here, a question like how you would go doing that thing, obviously your answer is you will go to library if you are an undergrad, or even you will consult our popular friend, that is Google Scholar. You will go to Google Scholar here and write the keywords to search about your particular topic. But this, when you search that way, let's say, for example, we wanna search, we are in the field of let's say bioinformatics, and we want to search about epigenetics. When we click and we search about these things, we will find a long list of results from this. As you can see here, we have this is probably the most cited paper in this field by this number of citation, or this one 2002, and so forth, and the list of course goes on and on. You can see here that you have more than 10 pages of researches, and each page includes a number of papers. This is clearly, undoubtedly, a tedious process if you would go and download all of these papers, and you need to read them. Let's say that one paper takes you 1 day to read if you are not that efficient. Reading all of these papers will take you a really long time. Needless to say how much time you will need for that process. Therefore, to make this thing easier, parallelly there is another field of research that has advanced in technologies that we can rely on, and that field of research name is domain mapping. This domain mapping is nothing but, as it is defined by this book, Terrorism, Informatics, Knowledge Management and Data Mining for Homeland Security. Let's not focus on that intriguing title. Let's just see for the definition of what domain mapping means. In the definition, we have that domain mapping involves mining, analyzing, charting, and visualizing a research area according to its experts, institutions, topics, publications, and social networks. And that simply means the people who are doing this kind of research in domain mapping, they're trying to look at the big picture of any domain. Let's say, for example, the domain of biology and so forth. So they would see what are by means of visualization, they would see who are the experts in this field, what kind of institutions are involved globally who are doing research in this field, and also what kind of subtopics in that big domain you would see, and the publications and the connections of these co-citation networks and the collaboration patterns you would see in that particular field of research. And this domain mapping comes in as a part of different kind of field of research. Most popularly is the scientometric. It's the same thing, but different terminologies, and also bibliometric. You will do that thing. Then how the people in this field do that research, because it's clearly here that they are contrary to most of us who are just looking for a part of the literature that we can go through, which are related to the tiny field of our research. Contrary, they are looking at the whole picture of what's there. For them to go through this literature, there are a number of tools. Most popularly, and the open source one, is what is called CiteSpace, and it is a topic of today's presentation. That's yes, I know you last time you asked me about this thing, so today I'm gonna explain what that CiteSpace means. That CiteSpace, basically the software is like this one, and it's invented by a very famous professor in the bibliometric analysis and or information science in general, and his name is Chao-Ming Chen. And okay, without more details, let's see what this software does to us. This software, the idea of the CiteSpace in general, is that when this presentation can show us more detail. When we have articles, that's papers, for example, this article one and another article, third article, any paper, it's structured in terms of title, as we know that, abstract, and then the topic, what are the methods involved there, the data collection and the results and so forth. And at the very bottom of any paper, you will have that field of references. These references include list of references that this research draws from. So for example, this article, let's suppose that the reference list of this article includes these areas. Just suppose that this area is the references. Also, another article includes some references, and these references maybe intersect with here. Maybe these two people co-cite a bunch of references, and here and so forth. So this CiteSpace is trying to analyze these research papers that we have them all, read their abstract titles, like literally goes on and read these papers for us. And the purpose is to let you have a bigger picture look of the research field you are looking at, and it will at the end it will tell you, for example, there are group of these papers, these papers or documents that resemble the intellectual base of this paper or bunch of papers. And it not only that, it will go on and give you some labeling for these clusters or a group of papers together. It will tell you that these group of papers tackle or talk about a very tiny subfield of your research, names, blah blah blah, let's say. Yeah, sorry for using that term. Then let's delve directly into how we can use this CiteSpace. As I have explained to you a while ago, that when you are searching your literature, you will go to the Google Scholar, and from that Google Scholar you will go and keyword search your articles, and you will find these results. But the software, which is CiteSpace, is okay, well, let's go and show you where is that. If you Google the keyword CiteSpace, which is stand for that software, you will eventually end up in this web page, with this title, and which is made basically for that CiteSpace software. And you can see that it has been applied to a big number of fields, research fields, and people have been applying it for bibliometric analysis, scientometrics analysis, and so on and so forth. And let's not get lost into that because today we are only focusing in a very particular field. That is, I'm going to explain to you how to use this software and narrow down or bring the only relevant papers to your research, from which you can then grab them and start reading and follow up with your research. And of course, to give the credit to this great professor, his name is Chao-Ming Cheng. If we click and visit his homepage here, you will find that his homepage at the University of Drexel here, and he has number of so many things here, and of course books he has written or co-authored with others, basically in this field of research. And also you can find him at ResearchGate if you having that social network, and in fact I'm following him there with others, and this is his homepage. Okay, then what's very important from this CiteSpace here is we need to get our copy of this software. To do so, we will go to we will visit this. Sorry, I drink a lot of this is tea. Today is not coffee. Okay, it's tea. Then we will go to this software. When you click on this software, it will open up in for me in a different window, and you will go directly. You will find here that this software it has the how to use. You can download it, and it's a book, or you can buy it in I don't know how to get it. Then there are the versions of this software. As of this recording or screen presentation, they have the latest version that is released last week, I guess. Yeah, or maybe yeah, today is 17. Today is April 17. So this one has been published in April 5th, 2017, and you can download this version. Of course, you will need Java, so you can go and download it. Okay, let's assume that you went there, you searched the software, and you download it, and you brought it for your work. Then when you download it, it's just you need to extract it, and then you will have the software here. For example, in my case, you will have all of these files. You will run it from this one, this that looks like the T or Java T. So you just double click in that one, and it will take some time to open. Then, as I have mentioned, yes, the software looks like this when you launch it. This is the first screen you would get, and it will tell you that how to cite CiteSpace. This is basically for the people who are working in bibliometric analysis or scientometrics analysis. If you are going there, if you are doing that kind of analysis or writing that kind of paper, obviously you will need to use this tool, and it's ethical to give credit to that software. So he's suggesting what kind of papers you need to cite in case you choose this option. And then here there is some acknowledgement, and it says that if you are using this CiteSpace, maybe may log user driven events for scholarly purposes. Do not proceed if you do not agree. That means just basically they will also collect some kind of data if you are using this this tool, and that's just okay. for the purpose of research. Okay, so to proceed, let's say I agree. Of course, every time you have to do this when you want to use the software. This is the first menu or the first screen that pops up when you open CiteSpace for the first time. It looks like this. It has these menus here from the file and so forth. So for you to use this thing, sometimes it comes with projects already loaded. This is the projects, so every project will have a title. Yeah, our project is nothing but a title. For example, if you are doing a bibliometric analysis, for example, the topic we have searched a while ago, that is the epigenetic, just okay, this is the epigenetic research or visualization of the literature or domain mapping or whatever you want to name it, and here. But in order for you to analyze these things, as I have explained to you how this software works, you will need the citation data themselves. So then how you can get this citation data? To get this citation data, of course, that Google Scholar is not enough. And I will show you why that is not enough. Because basically when we search, for example, here, that the Google Scholar thing, we don't get this, we didn't get, let's say, we will not get these references as you can see from output, because we said each article has title, abstract, and have a bunch of reference lists. We from Google Scholar results or outcomes here, you will not see, you will only see the title here and maybe a citation. Or if you want to cite, for example, some people confuse that, if you want to cite, maybe you will click here and you will get how to cite this particular paper. If you use it in your research, you will have that MLA formatting, APA, Chicago, Harvard, Vancouver, and so forth. But something that is very important and it's missing is we don't see that reference list. For example, if you have this epigenetica historical review or any kind of paper, when you click on that paper, you want to look at it, you will obviously see that the paper has abstract and introduction and here you can see that this paper has a title, and when you scroll down you will find also it has the part of abstract. And let's just go down there to show you, okay, here these references, we need to get this data, these references, which is like this paper itself cites a number of references, let's say 55 references. So we need the kind of data that we need to feed into this software called CiteSpace. Is this CiteSpace takes for each paper its title here and the authors, of course, and the abstract, this text of the abstract, because this software is actually reading the paper for you. Okay, it will read all the papers that are resulted by this your academic search engine. In this particular case, we say Google Scholar. You might have used another one, and then it will also use the references list, just to for it to be able to have this big picture view, and then it will go on and do the bunch of work for you and just present you with the very tiny part of research you want to do. And okay, so now that we know that we need data, I explained to you, usually that data we can get it from the Thomson Reuters Web of Science. That is, they call it Web of Science Core Collection. That is something similar. It's a sort of search engine, academic search engine, or indexing or referencing, similar to Google Scholar. But what is unique here is that it indexes the valuable or the good papers that are usually indexed by what we call it in academia. All of us, we know that ISI, for example, if you are a PhD student, some or most of the institutions will not allow you to graduate unless you have few papers, let's say 1, 2, 3 or 4 SCI papers published, and then you will be allowed to defend your thesis. Of course, this is also an opportunity or a chance to mention that I am, me myself, I am a PhD candidate now, and I am also in the process of finishing my PhD. Okay, back to the topic. So when you go to that Thomson Reuters Web of Science to get the data, most important thing is when you try to, when you keyword search something and you get this result as publication results, as we have seen there in Google Scholar, you will need to save this data. And when you are scoring down to save the data, you have to save to other file format, and then from there you will have to choose that the full record and citing references. Okay, but the thing is, when you need to download this, when you want to download this data, well, why don't we do that? Why, let me explain this to you. There is a small issue with this one. As I said, you will go to Thomson Reuters, and here you will need to search about Web of Science, Web of Science core collection. This one. Until last year, this Web of Science used to keep the index of Web of Science core collection, but from October last year, it's clear that this service has been maybe sold out to a different name or domain that is called Clarivate Analytics. You will find here Web of Science core collection, arts and humanities, citations. The thing has been transferred to Clarivate Analytics, and you will see more details here. Many of our intellectual property and science products are now part of Clarivate Analytics. For more information, so if you click this link, you will end up the page of this Clarivate Analytics. And needless to mention that even when it was a part of the Thomson Reuters Web of Science, or now as a Clarivate Analytics, we need to have it needs membership. You will not be able to download this data unless your institution, and most chances are high that most of the European and most of the global reputed universities, if you are doing your master's or PhD in one of these universities, there is an account from this institution. They will allow you will have to discuss with the librarian or the central library in your institution how you can get access to this Clarivate Analytics, or as I have said, the Web of Science core collection. Then you can go there and download your data. Okay, then to get this data, of course, now this is as I explained to you, it's getting here tedious, because this membership is usually it's not a cheap thing. And for this issue, number of researchers have complained, and in fact, in Nature, the popular science Nature publication has just published an article in Nature or Nature News that was, I think, last week. Yes. April 7, and a group of researchers are having new initiative. They call it Initiative Aims to Break Science Citation Paywall, and their concern is basically that why the Thomson Reuters Web of Science core collection that allows us to have the list of references, or what now we can have it here in Clarivate Analytics, why it is monetized, why it is by money. They are arguing here that this access to such data should be freely available for researchers and so forth. So anyhow, we hope for that to happen. And here, for publishers agree to release proprietary data on references in millions of papers, and this is like this initiative for open citations. Maybe they have already started and they have some few data. You have to check it out, and I will also check it myself. Okay, that's fair enough about the what is CiteSpace and how you will go to bring the data, as I explained to you, to get the data here. Then now, when you get the data, how that data looks like. Let me show you how that data looks like here. When you download the data and open it as a text file, you will find that, for example, here some Reuters Web of Science, that version and so forth, and you will find here, like example, AU is stand for the author, or here the paper type PT, it's the journal, and authors, these are the author list and affiliations of the authors, and then the title of the paper, TI, this is the title of that paper, probabilistic generative model for blah 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 blah, and also here where it's published, like IEEE computational intelligence, of course, and the language it uses, English, and it's an article, and then the IDs by the Web of Science, or this is usually the keywords when you write for the paper, for indexing your paper, algorithm, classification, and so forth. And then, as I explained to you, that abstract, the whole abstract of the paper, the text of that abstract is all written here. And then this one, CI, or it's, let's see the most important thing that we were all talking about. That is here, the citing references. You will find each reference cited in this paper. Here you see, including its document object ID to get that paper. And of course, this is a big number of papers and articles that I data set I downloaded about a particular topic. And most of the people, sometimes when they are using CiteSpace, they get some subtle error. That error is basically due to when you are downloading your data, make sure that you save the file as the first keyword download, and then you can put a trailer, anything else, or you can just download and then .text file, because if you don't do this thing, it will not work with you. Okay, now that we have our data, when we go to the software itself, I explained to you how when you open it this way, and the first thing you will want to do is to go to file here, or to a project, and make a new project. For your reference, you can name the project here, the title of your project, and the project home, where you want to save this project, and the data directory. Data directory are the data that we have just downloaded a while ago. Okay, so you need to tell where that data directory is, and then you can click save. And for me, because I already have something, I just cancel that one. I already have a project that I created here. For example, let's see, I call it mining API usage patterns, this one. And as you can see here, you can of course also modify it if you want to see the properties of this one, mining API using pattern. You will find here, if edit properties, it will tell you that the home of my project is this place, and the directory of the data saved here, and so forth. Okay, then when you have all of these things set up, the thing you need to specify is here. How long do you need this, or your data how long your data set spans? For example, when I search about my topic, that is mining API usage patterns, the papers, I have seen that it's from 1990 until 2016, last year. And then you will also need to specify to the tool what kind of terms or keywords it should use. You will, by default, you just leave the default. It will read the title, the abstract, the author, and keywords, and so forth. And here you will specify what kind of relationships you want to get out, like cited references or co-author and so forth. Here in the purpose of this presentation, which I told you, basically we are looking for a way to help you, and myself included, how to minimize the time consumed in reading literature in order to go for a particular research. Okay, so in my case now I set up my project and I will just click here go, and the software will start working. You will see here, as you can see, it's working, accumulating, basically reading all of these data about your files, if you can see, from 2008 2000 by year, and it will give you, when it's done, it will give you this kind of pop-up message, and it will tell you it show you how many records are there, how many references. You can see that 651 references. This is a whole bunch of big documents. You will never it's difficult for you to read. All right, it's clearly not difficult for you to read. Then when you need to click visualize, and you see here this beautiful process that starts here to visualize, to show you the relationship of your data in the process. You can see here on the left, these are the cited references, and here in the center, it's now processing the data. When you get this white screen, that means it is done. The software is done finding the relationship in your references or the papers, or it read it for you. Okay, so to have a clear view, you can here zoom in to it, and to see it in a clear vision here. As you can see, this beautiful network, in each network here, each node or a dot resembles a paper, and two papers will be connected together if there is a relationship between them. And what other interesting thing is, let's find it. Yes, here. Okay, fair enough. Okay, as you can see, these dots are papers, and the label here is the author of that paper and when that paper was published. For a clear view for that, you can increase here the font size to see, and this basically tell us that in this big field of API using pattern mining, there are like salient papers. Visually we can see them. If you are new to the field, you will obviously need to go and find these key papers and read them. But the most important thing is, now we are looking here for a way to narrow down our research to see. Now this is the big picture. I've told you from the beginning that the people here who are doing scientometrics or bibliometric analysis, they are interested in these kind of things, to have the big picture, who is who and what kind of significant papers are there and so forth. So for us to break down or narrow down our research paper that we need to read, we will go here in this thing, which means find clusters. Like, you are literally telling it to group these papers by topic. The papers that have similar topics or tackle similar issue, group them together, and eventually give me a title or a tag what these papers are talking about. Okay, so when you click this thing, you see now it is beautifully clustered here, and let's also zoom a little bit. Oops. You will see that it is beautifully has beautifully clustered them into groups, And we can even make these groups beautiful by increasing here, by playing on these parameters here, like the node size here, increase this node size, and so on and so forth. It's still clear that these papers are salient, the key papers. But for example, this color is a cluster, like basically this group of papers, because each dot here is a paper, are talking about a specific topic, and this group of papers also a specific topic, and so on and so forth. Okay. And then I told you that we group them, and we eventually try to put a label on them to see which papers are really relevant for us, just to go grab them and come and read them and follow on with our research, whether it is related work, part of a paper, or a literature review in our thesis, dissertation, and so on and so forth. Okay. To do so, the software, this tool, the CiteSpace, gives us number of ways we can label these clusters. For example, we can choose to label the clusters with abstract terms. That's the most frequent, or terms in the abstract that are shared in different abstracts. Then it will find the most frequent one or most significant one, and then it will put it as a label. Okay, and you can also, for the same thing, you can use label clusters with indexing terms, that the keywords you use in your paper, you make keywords, or you can use the title. For our purpose, let's say we choose to label them with abstract terms. When you click this one, it will gonna take some time, because it's again going to read all of these papers across the clusters and process them, and eventually it will show us here how it did it for us. I see you are excited and deep into the work. Yeah, I like it. Yes? Yeah. Okay. Here, as you can see, these are the labels made to each of our clusters here, as you can see, and of course you can manipulate that here by increasing the font of the label of the clusters. Here you can see that we have a number of clusters here. Okay. Now, fair enough, just for the purpose of illustration, you will see that each cluster will have a number. For example, this cluster is cluster number 10, and this is cluster number 2, and it is followed by the term, or what this cluster is talking about. For example, the cluster number 2 is tackling the subfield in software engineering, that's API methods or programmers, and cluster number 1 is violations and codes, and cluster number 10 is a software system interacts with like this thing, and here, for example, cluster number 5 is, or let's say cluster number 9 is software reuse through application programming interface. That means if you are just looking for software reuse research, you will have to go and download the papers here in this cluster, and these will resemble the intellectual base or the knowledge base of your research. You just take them, read them carefully, and then go about and follow that other research writing process, as you know how to organize them and so forth. So you can see that this software or this tool has helped you magically break down all of these big number of papers into just the relevant papers for your research is only this part, and then you go download them and work with it. Okay, you will obviously ask, where are the papers? This is just an image I am seeing, and how can I get that one? Okay, wait, I will explain it to you. The tool is sophisticated enough and include all of the things you need. Here, when you go to the export, you will find for example, this very good link that that's called generate narrative. And yes, it is, as you can see it, or as this title tells you, it generates when let's see, when you click on it, it will automatically generate narrative about this analysis to you, what has happened here. It will tell you that these are the major clusters, the major groups are included there. For example, it shows you the largest 10 clusters. The software has shown us that they are here, as we can see. There are a number of clusters, for example, 12 or maybe more. If you scroll down, you will see them all. But let's say they are 12. The narrative will show you the largest 8 of them. And in each cluster, as you see there, the cluster have a number and the size. Size means how many papers fall in that cluster. For example, in cluster 0, we have 61 papers. These are, if your topic, which is the label here, API usage pattern, if your topic is that one, you will need to go and download all of these 61 papers and read them carefully. Then you will have that chance of grasping the literature in your field, and so on and so forth for all of these papers. Not only that, it will show you down here after the table. For example, here it will show you that, for example, the largest cluster, that is cluster 0, has 61 members. This is the narrative I was talking about. And let's ignore these parameters because these are used by the bibliometric analyst, people who are doing that thing. And the most active citer to the cluster is this one. It will tell you that this paper has cited most of the papers there. This paper, that means maybe it's the most recent paper, 2014. It's titled Mining API Usage Pattern by Applying Method blah 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 blah. This paper, maybe it's your key paper, it's the recent one that mostly cite the papers in your cluster, and so on and so forth. And the second largest paper is this one, and so forth. So you will just need to go, and the good thing is you just click. If you click this link, it will take you to where you can download that paper, that particular paper. Okay, and another important thing is, now we know verbally that we have these kind of papers, and we have how to get the papers themselves. To get the papers themselves, go here to clusters, to this tab of clusters, and down here this cluster explorer. When you click this cluster explorer, it's as the name says, let's just leave it at default. Click OK here also, and you will see the whole clusters. I have explained to you a while ago that you have a big number of clusters. It's not only the clusters are not only 8 that has been shown in the narrative, but rather we have them here 19 clusters, or let's say 20, because it started from 0 to 19. We have 20 clusters. Let's assume that you are interested in cluster number 0, where, as you can see here, the terms of that cluster, API usage pattern, something. If you are concerned with this cluster, click here, check it, and you will find here the recent papers that mostly cite the papers in that cluster. These are your key papers. You're gonna go and read them, like this paper 2014, and this was 2009 and 2015. And not only that, I say there is 60 papers. There is also another paper here, this list. You also have to go and download them one by one and read them. This is the gist of this presentation. You will check here what kind of subfield you are looking for, and go download the papers and read them. Okay, let's say I am randomly just I'm interested in cluster 19, this topic, existing code, something. You will find that, oh, this is very nice, it has few papers in there. You just need to download these 3 papers, talk about these are the key papers there, and this one also you going to download them and get them there and get going. You start your research, the interesting part of that thing. Okay, then hopefully I hope that in this presentation I have given you the big picture of, if you want to go for a bibliometric analysis, what kind of popular tool is there for you to use, and have also introduced to you the field of domain map analysis. And most importantly, I have explained to you today how you can exploit, you can use this CiteSpace to help you get the only relevant papers on your research, the high quality papers, because we get them from ISI index papers. And I told you also that this process is not common. You cannot get it from your home. You need to have your access credentials, that is username and password, from your institution. They will show you. You gotta go to the central library there, or any librarian in your institution. He or she will tell you how to get access in that thing, or just from your supervisor, they will tell you. You just go there, keyword search this thing, download them, and start your research easily using this software. Thank you so much for your attention and the time. I really appreciate that thing. And again, for the social networks of this genius Professor Chao Ming Chen, you can go and have him. And for me, my name, for those who don't know me, my name is Ibrahim Musa, and I am currently a PhD candidate in Chungbuk National University, that is in one of the universities in South Korea, in the city of Cheongju. And I am also, as you can read here, I am a lecturer in Sudan University of Science and Technology. I have some of papers published, and as because this is academic something, you can, for example, check my contributions here. You will find that you will find I have a bunch of maybe papers. Some of them I authored or co-authored with others, and in particular you will find that I have 5 articles, 2 chapters, and conference papers, 7 conference papers, technical reports, and so on and so forth. And also you can find me if you go there to Google Scholar, just keyword search Ibrahim Musa Ishaq, and wow, yes, you go there, click this thing, you will find who is Ibrahim Musa Ishaq. He's a PhD candidate in database and bioinformatics laboratory, Chungbuk National University, and he is interested in the field of data mining and big data, and of course machine learning, bioinformatics, and scientometrics, and online social network, and so on and so forth. And also you will find this thing. I'm just a beginner like you, and let's wrap up this presentation here. I'm really glad that all of you today attended, and I'm gonna upload this thing in YouTube, and please, when you find it there, just, if you like it, click subscribe to my channel, and also like it, the like button, of course, if you like it. I would appreciate that, and I thank you in advance. And let's make this available online, and hopefully when I get time every weekend, I will try to put these kind of tips to help researchers, of course, aside from the paid courses I make, of course. Yeah, and that's it. Thank you so much for your time, and let's see you again.